Scientific notation. All right, guys, turn it off. We're gonna get on the scientific notation. So this is gonna be the next section that you're going to be quizzed on. Numbers that do not contain exponents are written in standard form. However, no, you're further this way, right? However, when you work with very large or very small numbers, it can be difficult to keep track of place value. So scientific notation is a compact way of writing very large or very small numbers. Guys, I shouldn't have to talk over you. Please don't be rude. Noah Lambert. All right. So scientific notation is a way of expressing a number as a product of a factor and an integer power of 10. So that's a lot of words. When the number is positive, the factor must be greater than or equal to 1 and less than 10. So what happens is there's something in the ones place, and then you have a decimal, and then you have digits after that. So for positive numbers written in scientific notation, we would write it as a times n, times 10 to some power, where a is greater than 1, but less than 10, and n is an integer. So n has to be a positive or a negative whole number, right? So here's an example. We would put the decimal point so that right between the 4 and the 2, so that this number stayed less than 10. And then we would multiply it by however times we would have to move our decimal point to get to that point. So this is times 10 to the 8th. But if I have a very small number, I would have to start here and move it to the left. So I'm multiplying by with a negative exponent. So we're going to see the difference of those two things as we go through our examples. So let's circle yes or no here to determine whether each number is written in scientific notation. You should probably get a piece of paper and write something down. I don't know what you did with your math book.
Me too.
All right. Is this number written in scientific notation?
No.
No, because this is bigger than 10. So we're going to say no. How about this one? This is page 44. All we did was turn the page. We were on page 43. Now we're on page 44. Cool. Is this in scientific notation? Well, it's greater than 1 and less than 10. This is raised to an integer, so we can say yes. The third one, this is still less than 10 and greater than 1. And this is raised to an integer, so we can say yes. This one, is this written in scientific notation?
No.
No, because it is not greater than 1. All right. So writing numbers in standard form. So we would write the power as a product. So 10 to the 4th is the same as 10 times 10 times 10 times 10. And then we would multiply. The other way that we would do it is we would write our number 5.34. If it is positive, we move to the right. Guys, close your Chromebooks. We're not playing Minecraft right now. Lucas, come get your book. It's probably over here. So if it's positive, we're moving the decimal point to the right. So we're moving it how many places to the right? Well, that 4 tells us how many places we're moving it. The number tells us how many places we're moving it. So if it's a 4, we're moving it 4 places. So we would move it 1, 2, 3, 4. What do you think I need to put in these other 2 places? Zeros. So this is 5.04 times. This is 1, 2, 3, 4 zeros. So 1, 2, 3, 4 zeros. And then when we multiply, you can put it into a calculator or you can move your decimal place 4 zeros and you should get 53,400. Method 2 is what I was just showing you. Move the decimal point 1 place to the right is a result of multiplying a number by 10. So when you multiply a number by 10 to the 4th, the decimal point moves 4 places to the right. So the exponent on the 10 indicates the number of places, in this case, 4. A positive exponent indicates the direction. So positive is to the right. So we have learned some very important things. Positive is to the right, and the power indicates the number of places we're moving it. Right, Michaela? Focused. So now, with that in mind, try the check on the bottom of page 44. I would start by rewriting this number. And what does this 5 mean? So a positive exponent indicates we're moving to the right, and the number tells us how many places. So try that check on page 44. Move that decimal point. Start by rewriting the number. All right. So it's positive. So how many places are we moving it? 5 places. So I'm counting 1, 2, 3, 4, 5. What do I need to put in these 2 extra places? 0. So then I would just rewrite it. 993,100. 993,100. Well, let's do example 2. All right. Here's an example with a negative exponent. We're going to write the power as a product. So 10 to the negative first, we have 3 times. So 1/10 times 1/10 times 1/10 is 3.27 times 1 over 1,000, which is the same as 3.27 divided by 1,000. So you can plug that into your calculator. Because this is being multiplied by the 1, so you end up with 3.27 over 1,000 when you multiply. All right. Good question though. So 3.27 divided by 1,000. Oh look, they gave it to us in scientific notation. Real nice. They gave this to us in scientific notation. We're supposed to write it as a product. So we'll have to move this. Dividing by 1,000 means we're moving to the left 1, 2, 3 zeros. What do we need in those places? 2 more zeros. So 0.00327. And that's what they got here as well. So we essentially move the decimal point when we divide by tens, right? The number of zeros when we divide by tens, or move the decimal point when we multiply by tens. Here, since we have a negative exponent, we're dividing by tens. When you divide a number by 10, the decimal point moves one place to the left. So dividing by 10 is the same as multiplying by 10 to the negative 1. So when you multiply a number by 10 to the negative third, the decimal point moves 3 places to the left. The exponent on the power of 10 indicates the number of places. In this case, there are 3. A negative sign on the exponent indicates the direction to the left. So here's the next important thing. So if it's a negative exponent, we're moving to the left. That's correct. Not right. All right. So start by rewriting this check and decide if you're moving right or left and how many you're moving your decimal point. Try that check on page 45. Okay, are we moving left or right? We're going to move left because it is negative. So how many times am I moving left? In this case, it's not 3, it's a 4. So it's negative 4. So 4 to the left, we would go 1, 2, 3, 4. And we need zeros here. So I would rewrite this 0 point, and then I have 3 zeros. 1, 2, 3, 6, 0, 2. So that would be in standard form. Okay? So let's try on page 52, 53. Page 53, numbers 1 and 2. Try these extra problems. How are we moving those decimals? And then we're going to look at what it looks like on our calculator, which we kind of already have. Gotten a sneak peek today. Page 53. Numbers 1 and 2. Start by writing out that number. Move your decimal. Decide if you're moving right or left and how many. Guys, this should only take a couple minutes. Finish that up. So we start by rewriting the number. Shh. Turn your voices off. When we rewrite the number, we're moving it 3 places to the right. So we would go 1, 2, 3. And what do we need in these places? Zeros. So 1,600 would be in standard form. And here, instead of moving to the right, we're going to move to the left. So, Noah, guys, I'm going to have you move back to your assigned seats if you can't get it together. 1.49. Are we going to the left or the right? It's negative, so we're going to go left. How many places? 7. 1, 2, 3, 4, 5, 6, 7. That's where my decimal place is going. So I need 1, 2, 3, 4, 5, 6 zeros after my decimal point. So I'm going to put a 0 here, and then I'm going to put my decimal point, and then I had 6 zeros. 1, 2, 3, 4, 5, 6, and then 149. Okay. All right, let's look at what a calculator shows on page 46. So this is page 46. All right, there is a quick video here. All right. I wanted to show you the quick video. This is 1-5 in reveal. 8th graders, turn your voices off. It doesn't want to open. Our reveal doesn't want to open. Sad day. Sometimes technology doesn't work the way it's planned, right? I've tried twice. All right. So the animation was supposed to show that a calculator will convert numbers to scientific notation only if they are very small or very large. The value after the E represents the exponent on the power of 10. So when that's not a calculator, when we were doing that problem on this page here, when we said 3.27 divided by 1,000, guys, stop. See how your calculator looks? It says times 10, and then it has this little thing to the negative 0.3. So that would be 10 to the negative third. So our calculators can help us with scientific notation. So their calculator is saying E as 10 to the 11th. So this means 8 times 10 to the 11th e to the negative 12 means 2.5 times 10 to the negative 12. So it's, you might see it a little bit differently depending on the calculator you use. I know some of you guys like to turn your iPhones to the side and use them as a scientific calculator. So be sure you know what it looks like. So type the number that is multiplied by the power of 10, press the second button, press the EE button. Let's see. On ours, it doesn't look like we have this. So on ours, we would have to, say, 3.25 times 10, and this is your caret, and then you could use the opposite of 3, and it would give you that. So let's look at this example here. So this means 4 times 10 to the negative 7 on our calculator. So 4 is the factor and negative 7 is the exponent. So write the number in standard form. Well, we have to move the decimal places. How many? The decimal point, how many places? How many places are we moving it? That's a 7. And are we moving it to the left or the right? Negative means we're moving to the left. So if we did that, if we wrote 4, our decimal point would be right here, right? And if we move this 7 places to the left, 1, 2, 3, 4, 5, 6, 7, here becomes our decimal place, and we have 6 decimals. All right, I know you think your conversations are really important right now, but I'm getting extremely frustrated. I have tried to be patient and I'm done. Done being patient. Turn your voices off now. Quit playing your stupid video games now. All right, check your understanding of that here. If you see this on your calculator, 2.4, and on yours it'll say 10, a teeny tiny 10 to the negative 3. What does that mean? It means we have that 2.4, so rewrite 2.4, you're moving your decimal to the left or the right. If it's negative, we're moving left. And how many places? 3. So 1, 2, 3. Which one of these answers matches that? This one, right? What else? This is 2.4 times 10 to the negative 3, right? So this one as well. It's not 2.4 to the negative 3rd though. All right, so that is a little bit about your calculator. Go ahead and finish those couple questions. So 1 through 4 should be done. So try 3 and 4 from examples 3. You're going to write those numbers in standard form. if we see this in a calculator, it means 8.3 times 10 to the negative 6. So use what you know. We're moving to the left 6 places to rewrite this. This would be 7 times 10 to the 11th. So use what you know, rewrite that, and move your decimal to the right 11 places. All right, so if I were trying to figure this out, I would rewrite this, and then I would say this is negative, so I'm moving to the left, and I'm moving that number of times, which is 6. So I would count 1, 2, 3, 4, 5, 6. So I'm filling in these empty places with zeros. So you should end up with 0 point, and then you have 1, 2, 3, 4, 5 zeros after the decimal, and then 8, 3. That's how I would write that in standard form. Did you guys do number 4 in standard form? So 7 has a decimal point right here. So if I was moving it 11 times, I'm actually adding 11 zeros, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's a lot of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it becomes 7 with 11 zeros after it. 3, 6, 9, 10, 11. So every 3 from the right. So 1,000, million, billion, 700 billion. That's a pretty big number. Tomorrow, we're going to look at how we would write these in scientific notation, and that typically becomes the most difficult as far as conceptually understanding that.